Earlier I did this proof on the slope of perpendicular lines. So if we have a line here that has a slope of 2/3, a parallel slope would look like this. So what would you say the slope is? Well, the slope would also be 2/3. But let's say we're not interested in a parallel slope. We're interested in a slope that makes an angle of 90 with the other line, and it can be anywhere along the line. What would that slope be? Well, we know that if this red is positive, this blue one is going to end up being negative. And as far as the rest, it's hard to tell what it's going to be. So we're going to prove what it is. You already know it's the negative reciprocal, but we're going to prove it. And when I proved it last week or earlier, I made a little mistake, and I want to fix that. So we're going to make two lines going through the origin perpendicular to each other, so they form a 90-degree angle. We're going to go over one, and then using y equal mx plus b, I'm going to go y equal mx plus b, and we're going to use slope equal to m2 for this one. And then what we'll do is we'll start at x equal to 1. So y equal to m2 times 1 plus, and the y-intercept line goes through the origin. So y is going to be m2. And so there's my point, 1, m2. Similarly, with this other line, we're going to have the slope of m1. And if that slope is m1, we're going to be going the other way. So we're going to just look at it going through x equal to -1. So if x is -1, slope is m1, you get y equal to m1 times -1 plus b. And b is 0 because it goes through the origin. So y is equal to negative m1. So that's why it looks kind of weird that this one on the left is -1 m1, and this one on the right is 1 m2. But that's the reason, is because when that x is +1, the slope will be positive. When this m is -1, that slope will indicate as the opposite of m1. All right, so once you have 3 points, okay, now what you can do is you can use the distance formula. Distance is the square root of the change in x squared plus the change in y squared. Okay, if you square both sides, what you end up with is d squared equals the change in x squared plus the change in y squared. And notice there's no square root to contend with. A wonderful, wonderful thing. And that's what I made the mistake with before. So we don't need to have any square roots. So d3 is going to be 1 minus -1 squared plus m2 minus m1 squared. And it is minus a negative m1, so that'll be plus. Distance 1, that's this guy. Well, that's from these two, and we're going to go negative m1 minus 0. Well, let's do it this way. 0 minus -1, m1 squared, plus 0 minus -1 squared, and that's d1. Now we're going to do this d2, which is going to be squared, will be m2 minus 0 squared plus 1 minus 0 squared. Simplifying, you get 2 squared plus m2 plus m1 squared equals m1 squared plus 1 plus m2 squared plus 1. And some great things are going to happen here. This is going to be 4 plus m2 squared plus 2m2m1 plus m1 squared equals m1 squared plus m2 squared plus 2. And if we subtract 2 from both sides, you're going to get 2. And the m2 squareds are going to cancel, and the m1 squareds are going to cancel. So you'll get 4 minus 2 is 2, plus 2, m2, m1 equals 0. So if I move this 2 over to the other side, I get 2m2, m1 equals negative 2. Divide both sides by 2m2, and you get the final wonderful, predictable formula that you know about. It's negative 1 over m2, or as we usually call the negative reciprocal. Isn't that neat? So there's the proof. So if your slope is equal to 2/3, the parallel slope is 2/3, but the perpendicular slope is negative 1 over 2/3, or as most people would write it, negative 3/2. And that's how you derive the formula for perpendicular lines and their slopes.